Okay, class, today I would like to work some of the examples that were on our homework the other day. So let's see if we can just kind of just run through this. Maybe this will help you understand solving two-step equations a little bit better. Okay, so these are just a few more examples of how we work these problems, or how I would like for you to work these problems. Okay, so this was our first question on the assignment. We've got 3g plus 5 equals 17. Well, what we need to remember, our ultimate goal is to get this variable by itself. So in order to do that, I first have to get rid of the plus 5, and then I need to get rid of the multiply by 3. Okay, so that's what I'm looking for. So in order to do that, I first need to get rid of this plus 5. Okay, so we're going to do that by adding its opposite. So you should do 3g plus 5, and then plus negative 5. It's opposite, and that will make this 5 go away. And if I add one thing to one side, I have to add the same thing to the other side. So I would do 17 plus negative 5. Sometimes it helps if you underline the thing that you did new, so you know you put it on the other side. So now these 5s will zero out, and they turn to 0, and we're left with just 3g, which is equal to, and when we put 17 and negative 5 together, we end up with 12. Now, to get rid of a multiply by 3, I don't really want to know how much 3g's are worth. I only want to know about 1g. So to turn 3g into 1g, you just divide by 3. Whatever this number is, that's the number that you divide by. And if you do that on one side, you have to do it to the other as well. And you end up with g is equal to 4. And if you were to plug this 4 back into the original equation, you could check to see if this is correct. So you do 3 times 4, plug the 4 in for where the g is at, and we add 5. 3 times 4 is 12, plus 5 does give me 17. So it does check off. So, number 2. This one, the only thing that was different was that the 4a is on the other side. Now, there are several ways that you could work this one. I choose to work it just like this. But because of this equal sign right here, you can flip-flop these two sides if you so choose. So you could write this as 4a plus 13 is equal to 9, and it would say the same thing. Okay, but I'm going to keep it exactly the way it is, and I'm going to start on the side that has the letter and get rid of the thing that doesn't have the letter. So I'm going to start at the equal sign and just write 4a plus 13, and to get rid of the 13, I add a negative 13. So I come over to the other side and I write 9 plus, and the new thing I added was a negative 13. So I write negative 13. Now we simplify this problem. So we get 9 plus negative 13 gives us negative 4, which is equal to, and my 13's go away, so we're left with 4a. Now I don't want to know about 4a, I only want to know about one of them. So I divide by 4, and I end up with a equaling negative 1. Okay. Number 3. Now this one brings in another monster, a minus problem. Now the way I work these problems, and I've worked them for years this way, if you look at my answer key, this is what I do. I don't like minus problems. I'm going to change them. So I'm going to change subtraction to addition and my next number to its opposite. And the reason why I do that is because subtraction does not have commutativity. Addition does. So if I were to flip this around, if it's a plus problem, then no matter how I flip it or however I write my numbers, I can still get the right answer. So I start with the equal sign. I still need to get rid of this negative 2. So 5m plus negative 2 plus positive 2. So 13 plus 2. So those are the two things that were new. I had the negative, so I added its opposite. So we end up on this side with a 15, which is equal to 5m, because my 2's cancel each other out. Then I divide by 5, and we end up with m equaling 3. Okay, let's try another one. Now this one brings in fractions. So in the other ones, we had a number beside the letter. But now we have a number below the letter. So that brings in something else. So what we do to solve this one, again, we start with the side that has the letter, get rid of the thing that doesn't have the letter. So I'm getting rid of this 6. So we do it the same way. 6 plus negative 6 plus n over 5 equals negative 4 plus negative 6, because that's the new thing. So on the left-hand side, I end up with n over 5, which is equal to negative 10. Okay? Now this is a divide by 5, or another way of writing that would be 1/5 n is equal to negative 10. Both of those say the same thing. So in order to get rid of a divide by 5, we do its opposite, which is a multiply by 5. So I'm going to put a 5 up here beside the n, and I'll put a 5 over here beside the negative 10. So now this 5 will zap out this 5. They divide out and they become a 1, which is what I want. 1n equals, and then negative 10 times 5 gives me negative 50. Now really what's happening here, this n has a 1 in front of it. So that's why I put the 1/5, and we could pull the n out. Now in order to get rid of a multiply by 1/5, what you really have to do is do a divide by 1/5. Because to get rid of a multiply, you do a divide. Well, in fractions, we know that if I'm going to divide fractions, to divide fractions, don't ask why, flip the second and multiply. So what we really do is we multiply by its reciprocal. Multiply by 5 over 1. Okay? So that's really what we're doing. Okay? So if I multiply this side by 5 over 1, which now my 5 over 1 and my 1/5 will divide out, and I end up with n is equal to, and then I have to do the same thing over here. I have to multiply it by 5 over 1, which is just 5. And we still get negative 50. But we have to understand this idea of a fraction and how to deal with that, because you will have problems that have fractions in them. Okay, let's try another one. Now this one posed quite a bit of problem in class, because what we want to do is we don't want to follow the rule for this subtraction. Remember, subtraction is change subtraction to addition, the next number to its opposite. Just because the 4 is over here, that doesn't mean we always change it to its opposite. It's the very next number. So now, to solve this one, I need to get rid of the 4. So 4 plus negative 4 plus negative 3y is equal to 31 plus negative 4, because the negative 4 was what was new. So the 4's turn to 0, and I'm left with negative 3y, which is equal to, and 31 plus negative 4 gives me 27. Now I divide by negative 3, divide by negative 3, and remember, whatever this number is, that's what I divide by, even if it's negative. And you end up with y is equal to negative 9. Okay, negative 9. Okay, now to some of the last two questions that we had problems with. Okay, number 7 here. In this one, we've got that fraction here. Okay, so that was what I was talking about on this previous problem on what to do with that fraction. Okay, so we start off by changing subtraction to addition, and now I need to get rid of that negative 6. So negative 1/3 y plus negative 6 plus positive 6 equals negative 11 plus positive 6. So my 6's go away, and I'm left with negative 1/3 y equals, and negative 11 plus 6 gives me negative 5. Okay. Now to get rid of this negative 1/3, okay, I have a multiply by negative 1/3, so I do a divide by negative 1/3, which means I multiply by its reciprocal. So you're going to multiply by negative 3 over 1. And if I multiply this side by negative 3 over 1, I'm going to multiply this other side by its value. And the value of negative 3 over 1 is just negative 3. Okay, so these divide out, become 1. We end up with y is equal to negative 5 times negative 3 gives me positive 15. And then the last problem I want to look at today is one that has 2 letters in it, but the letters happen to be the same. So I will start the same way. I'll start by changing my minus to a plus next to its opposite, and now I need to simplify my m's. Well, if this is a negative 7m and this is a 9m, as long as my letters are the same, I can put them together. So I end up with 5 plus a negative 7 and 9 make 2m equals 11. So now this looks just like all the other problems. I get rid of the 5. So 5 plus negative 5 plus 2m equals 11 plus negative 5, because that was the new thing that I added. We end up with 2m equals 6. And now I divide by 2, and m is equal to 3. So I hope that helps explain solving two-step equations a little bit better.